Hello students, welcome to RD Chemistry. In this video, I'll explain the concept of Heisenberg Uncertainty Principle. What is the Heisenberg Uncertainty Principle? It is impossible to measure simultaneously both position and velocity or momentum of a microscopic particle with absolute accuracy or certainty. Okay, so there will be error in the position as well as the velocity or momentum. Position, let me take that as the x, velocity in terms of v, and moment in terms of p. You know that momentum p is equal to mass into velocity. There will be error, and errors are the difference in the error, difference in the velocity, or difference in the momentum. So the product of these two errors, that is the delta x into delta p, either greater or equal to h divided by 4 pi, and this is according to Uncertainty principle. Okay, now p is equal to mass into velocity. The change in is equal to difference in mass into velocity. Mass cannot be varied, mass is a constant, so therefore it is a mass into change in the velocity. Therefore delta x into m into delta v is greater than equal to h divided by 4 pi. Okay, or in terms of energy and time, we have also the formula difference error in the energy into error in the time is also equal to or greater than h divided by 4 pi, and this h is equal to Planck's constant. Okay, read the question. Alveoli are tiny sacs of air in the lungs whose average diameter is 50 picometers. Consider an oxygen molecule trapped within the sac. Calculate uncertainty in the velocity delta v. You have to calculate for oxygen molecule. They are given an oxygen molecule, single oxygen molecule. Okay, so we have the formula delta x into m into delta v is equal to, for calculation we'll do, is equal to h divided by 4 pi. So uncertain the velocity delta v would be equal to h divided by 4 pi into m into delta x. H value, you know that it is 6.626 into 10 to the power minus 34 into joules a second. You remember this number. Generally it will be given within brackets, divided by 4 into 3.14 into, now you know that molar mass of the oxygen is equal to 32 gram per mole. We are tried in terms of SI unit, kg at bring in. So 32 into 10 power minus 3 kg per mole. You know that if we go for per mole, Avogadro number of molecules are there, but I want it for single molecule, not per mole. So for single molecule, this is for Avogadro number. So divide by the Avogadro number. So 32 into 10 power minus 3 kg divided by Avogadro number 6.023 into 10 power 23. So many kgs per molecule it will be. Okay. So it is a 32 into 10 power minus 3 kg divided by here, divided by 6.023 into 10 power 23. Okay. Into delta x. Delta x is a change in the position. So we'll be writing in terms of diameter here 50. 50 picometer. Pico means 10 power minus 12 meter. So on rearranging all these, we are going to get 19.8 meter per second we are going to get. Okay. Hope this is clear to you. The next question is, if the light of wavelength given lambda is used to detect an electron, then the uncertainty in the velocity will be equal to. So same thing it is. Delta x into m into delta v is equal to h divided by 4 pi. So uncertain the velocity is equal to h divided by 4 pi into m into delta x is equal to 6.626 into 10 power minus 34, which is the Planck's constant, divided by 4 into 3.14 pi value into mass of the electron. Will have to remember, or it will be given within brackets. It is a 9.1 into 10 power minus 31 kgs in terms of kgs. Okay, all are in SI unit into kgs. It is. Then delta x, they are given some centimeter here. Understood the position, distance. Convert into the meters. 5.77 into 10 power minus 2 little bit, right? So 5.77 into 10 power minus 12. Okay, so on reading all this, finally we are going to get 10 power 7 meter per second. Okay, right? Next question. Uncertain in the position and velocity of the particle are zero point 0.1 nanometer and 5.27 into 10 power minus 24 meter per second respectively. This is uncertainty in the position, which will be equal to 0.1 into 10 power minus 9 meters, nanometer, right? So it is equal to 10 power minus 10 meter to be. And here it is already given in SI unit. Mass of the particle will have to calculate. Same thing. Delta x into m into delta v is equal to h divided by 4 pi. Correct? So mass is equal to h divided by 4 pi into delta x into delta v. Correct? H value 6.626 into 10 power minus 34 divided by 4 into 3.14 into delta x 10 power minus 10 into velocity 5.27 into 10 power minus 24. Correct? So here we get the mass because we have substituted all the value in terms of SI unit. We'll be getting in terms of kgs. Correct? You proceed with this question. I'll give you only the option. See, the options are 200 grams. Option B, let me give 300 grams. Option C, 100 grams. Option D, 1000 grams. Okay. Select the closest answer. All the best. Please do like, share and subscribe RD Chemistry and support me. Thank you for watching. Have a nice day.